I am writing a compiler for the ELNA programming language. The compiler is written in itself and only uses the features that are already implemented. And I was working lately on the separation of the code generation in two stages, in 3 address code and register transfer language. Register transfer language is basically assembly for now, and the compiler itself supports only one architecture. This is RISC-V 32-bit, and I'm working in a virtual machine. Last time I moved the logic for setting up the hardware registers into assembly, into the assembly path, because it is where the registers should be allocated, because the early version of the compiler was a single pass compiler, so everything was done in a single in a single pass. And now when the caller side is set just before assembly, printing, writing of the assembly instructions, we also need to do the same for the procedure side, for the callee side. So our procedures get its arguments into the registers A0, A1, and so forth. And when we enter in the procedure, we need to save these registers on the stack, so they won't be overwritten, since these registers are not preserved registers. So we need to save them on the stack and use the values from the stack. This ELNA TIC parameters procedure generates 3 address code for the procedure from the abstract syntax tree. So AST_list is a list of parameters, and to generate the code for saving the parameters, the 3 address code should save the parameters of the procedure itself. It isn't the case currently, or I just implemented it, that I go through all the parameters and count the number of parameters I have, because I only have a list of parameters in the abstract syntax tree. And after that, I allocate an array of 8 bytes. So 4 bytes for the name pointer and 4 bytes for the length of the variable, and I save them in an array. This procedure then saves the pointer to the parameter list and number of the parameters into the past variables, and we save both values in the result structure that we return. So actually here it should be everything we need. Now we need to find the code generation for this. for this register transfer language, when we start to convert the 3 address code into RTL, we should also add instructions that save the registers with parameters onto the stack. Here we have ELNA alloc procedure. So it allocates the stack and it starts the stack allocation after the first 32 bytes. This is actually what we want to get rid of. So these 32 bytes are used as a static place on the stack in each procedure for saving the parameters, but we want to allocate stack dynamically, so not always 32 bytes, but every time as much as we need and not more. I actually think that ELNA alloc procedures, ELNA alloc path is called after this ELNA RTL path. So let us just go through this ELNA RTL module. So then we call ELNA RTL procedures. So this is the code that translates a list of procedures from 3 address code into assembly. And this procedure then calls ELNA RTL procedure declaration, and this is actually what we need. So here we just allocate a structure to save the assembly instructions belonging to a single function. And we read the parameters from this TAC declaration. So let us define an additional procedure here, RTL procedure parameters, and it will get the list of parameters, I think, or we do it later. So we've defined a procedure, and before we call the code for the procedure generation, we call the code for the parameters. They actually should be merged together, so the code for the parameters saving and for the instructions from the body itself, they go to the body or the assembly function, so they should be merged. I think that we just define an additional variable, and it will also be a pointer. No, it won't be in pointer. I think instruction list is the correct type. Oh. Okay, that's fine, and we assign the result of this ELNA RTL procedure parameters to this body variable, And on this side we need a result variable, for example. We just set its type to Word. Word is a placeholder type for now because I haven't implemented a type checker yet. So the types aren't checked anyway, but there are a few places where the type are used, for example, to access record fields, and we return the result at the end. So TIC declaration, and I assign, so let us go back to the ELNA TIC parameters, I think. Yes. We need to go to the procedure where it is used exactly, and result has these two fields, parameters and count, and we pass them to this. Only it is of course not result, it is a TIC declaration, count, and TIC declaration parameters. We check whether this works. And now we can add these parameters here, so we call them the same parameters of the word and count, and the parameter count. Now we can define a variable parameter index, and we should set the result to nil so it doesn't return garbage if we have no parameters, and parameter index is 0 in the beginning. And then we need to implement a loop. I haven't implemented while loops yet, so I use labels and gotos to jump. We define a label in RTL procedure. Why? We can just call it parameters because there aren't other parameters except for the procedure, so we just call it parameters, and the label is then called parameters loop, for example. So labels begin, label declarations begin with a period, but when we jump to this label, we skip the period. So if parameter index is less than count, then we say that parameter index is parameter index plus 1, and then we jump to this ELNA RTL parameters loop again. So we just need to store each variable, each pass parameter on the stack. For the stack values, we can use so-called pseudo registers. But first we need the name, or let us allocate an instruction. I have special create functions for creating instructions. I think Elna RTL instruction create. Exactly, and I just assign it to the result first, but we will need more variables in a second. So basically we want to move a value in a register to a pseudo variable. So we create a move instruction. I think it is mv or move. This is an interesting question. It is move, Elna RTL operator move. It's not a real RISC-V instruction. Yeah, RTL is not a poor assembly, but it is a language that is very, very similar to the assembly language, but there are still some changes that need to be done before writing assembly. So we generate a move instruction. Move instruction has two arguments. The first argument is the target. So we say an instruction set operand, and we set the operand in the result type, and this is the first operand, and the target of the first operand is the target, the type of the first operand is Elna RTL operand pseudo, and we need here two values. So pseudo registers have names, and the both zeros are basically name pointer and name length, but we need to read them first. So we create the variable parameter name and parameter, or name length, actually name length word, and the first byte of this parameters array will be the name. So I just assign it to a parameter name. So parameters, the reference parameters. Then we need to increment to move forward in these parameters array. So we add 4 bytes to it to go to the next field. Seems fine, and the next field is the length, parameter name length. So we assign again the reference parameters to it, and then we go to the next array element, and this parameter name and name length has to be passed to this to this set operand call. So let us move it a bit, and then we need the second operand. The second operand is their register, and we start with A0, and we have this parameter index, so we have to append this parameter index to A to get the proper register. I have actually an enumeration with all registers, and I think that A0 is actually X11. So RISC-V has these X registers, so each register has two names. A0, A1 are arguments, T0, T1 are temporary variables, and there are these X registers. These are the same registers, but they do not have this special prefix AT, but they are just all X registers, X1, X2, X3, and A0 I think is X10. So we set the second operand, instruction set operand on the result. This is the second operand, and the operand type is a register, and the register that we set is 11 because the first register begins with 0 register X0, but this procedure starts to count with 1 and not 0, so we add additionally 1 plus parameter index, and since the length of the argument doesn't apply to the registers, we set it to 0, and that should be it, I think. Now the problem is, of course, if we have multiple registers, then we override the result each time. Result, let us add a variable instruction, and probably something like last instruction. So result is actually, result should be the first instruction that we generate. Let us then define current instruction and last instruction, because we need to return a list of instructions or nil. And what we will do, we will check if result is nil. Then we can do what we can do this stuff basically independently. We just save it into a different variable, not result, but current instruction. If result is nil, then result becomes the current instruction and it doesn't change anymore. Otherwise we should append the current instruction to the last instruction we generated. We can do it with ELNA RTL instruction set next, I think at least. RTL instruction set next. No. I call this concatenate procedure. Do we have other cases? Yeah, basically everywhere I call this ELNA instruction list concatenate. ELNA RTL instruction list concatenate. And what lists do we merge? We merge the last instruction with the current instruction, and that's it. After that we need to say that the last instruction is current instruction, I think. So it will then always keep a reference to the lately generated instruction. Undefined reference to ELNA instruction list. ELNA RTL instruction list concatenate. So then we return this instruction list. In the result variable we still won't see any changes because we do not use the result of this procedure. We need a second variable here, we call it parameters. And we assign the result of this ELNA RTL parameters call to the parameters variable, and we assign this thing to the body variable, and after that we can to the body variable, and after that we can assign body to it. And now the only thing is that we can say that parameters are elna rtl it's just instruction list concatenate elna instruction list concatenate and first go the parameters and then the body, and then we should be able to assign parameters to the body. Okay, it compiles. We will look in a second into the generated assembly. I want to move this code to the top half, so we look for the elna rtl procedure declaration here and find it in here. I think that we can shorten this a bit by assigning the result of the concatenation directly to the result body, and that's it. So we compile it once again. Let us open the generated assembly file under state 17 and CLS. We need to find a procedure with parameters. So for example, this is the same procedure, this elna rtl procedure declaration. And I do not see any changes here. This is actually what we're looking for, so we write x10 or a0 to the stack position with 32 bytes, and here we do the same, but we first write x10 into x5 and then we save it in 28th position. So this actually could work in. Yes, these both lines do the same. So these two just use an immediate register x5, x10 move to x5 first, and then x5 is saved on the stack, and here we directly write x10 onto the stack, but they are doing basically the same. They save the only parameter of this procedure on the stack. So it may actually work. Now we need to refer the one line is generated, the first line is generated by the new code, and the two following lines are generated by the old procedure that we are replacing. I'm just thinking, how can I, but the code that refers to the parameter will use the old stack position, so 2028 relative to the stack pointer, and we need to use this new pseudo registers. Somewhere I had a procedure that checked whether a variable is parameter or not. Let us search for LNTAC operand stack, I think, because there should be a check. Yes, this is this place where we're looking whether the variable is a parameter or not. So we encounter a variable, and this variable can be a local variable, a global variable, or a parameter. And if lookup result kind temporary info, else we do this thing here. But this is for, no, this is for global variable. So if lookup result fails, if the variable name is not in the local symbol table, then it is assumed to be a global variable. So we actually need this if else case. And in this else case, we check whether this thing is temporary info. Temporary info means information saved about a local variable, and we just need to remove this check, I think. Oh, it will break. No, it won't break, but it works. It works as expected. So we do not, this LNTAC operand stack, the stack operand is basically an TAC, three address code operand, that saves the stack relative position of the variable, and we want to get rid of this kind of operands completely in the three address code, since it shouldn't care about exact stack position of local variables and arguments. So this can be removed. We do not need this anymore. And we check once again whether the compiler can compile itself, and theoretically we can also remove some code in a few other places. The one being the old routine for generating these assembly instructions, and we will actually even optimize the code a bit, since as we can see, the old code generates two instructions for each variable, and the new code, the old code generates two instructions, and the old code generates a single instruction. So we also will write a few instructions less than before. We actually were there. That was this NTAC parameters procedure. And this procedure generates additional instructions and return them. A simple test would be to return a nil instead of first instruction, since we do not generate any code here. Just save the parameters in the parameter array. Yes, that works. So that can go, and now we can remove this stuff. And we do not even need to do a symbol table lookup here. And that's it, I think. We can remove a few variables that we do not use anymore. One of them being this first instruction. So we do not need this and this. Then name point, name length. I do not know if I use them. No, I do not. So they can be removed. Then this instruction and current instruction both can be removed. And then this symbol info isn't used, I think. Asked parameter is used. Parameter index and current parameter. Sorry, I haven't seen the result. No, it looks fine. And current parameter should be used, I think. Yes, current parameter is used. Now we can reduce the number of parameters for this procedure. The first change is that we do not need the symbol table in this procedure anymore. So let us just remove the symbol table reference, and when we go to this function we can remove the symbol table reference here. And probably we need a symbol table a bit later for the body, for converting the body of the procedure. So we still need this new symbol table variable and the lookup, but I think that I actually do not need this variable, so I assign a symbol info. I assign the result of a lookup to the symbol info variable, and then I get a field from this variable, but I actually can use this directly instead of the variable. It would mean that I can remove this line, and I probably can remove the variable itself, this new symbol table. So now we can remove, now since we do not need the return value anymore, we can remove the parameter list or parameter count as a return value, and I would say let us go with the parameter list. So we go back to this procedure and we say that we do not return nil, but we return this parameter list. It is called parameter list also on this side. So we just say that we return this argument. Yeah, I probably should just remove the argument and use a local variable, and then I return the value of this local variable. Let us go for it. So we remove this parameter list from here, and we define it as a simple local variable of type parameter list. Then we use it. It is not, we shouldn't dereference it. Parameter list, and the last thing that we do in this procedure is to return this parameter list, and then we go to this LNT-AC parameters, and we remove it from here, but we assign the result of the procedure to this parameter list variable. And I broke something. So LNT-AC parameters, parameter list is a word. The second argument is this parameter count, and we assign a value to it, parameter list. We allocate memory and assign to this variable, and then we assign it. Oh, but actually it is a newly allocated array. Malloc should probably return nil if it has no parameters. But we do not change this parameter list in any way. We just allocate memory and we return this memory. Parameter list, I allocate memory. And I return a pointer to this memory. And here I assign it. Oh, it's not the problem. Of course it's not a problem. We do not assign the previous variable that was assigned was this first instruction variable, and now this first instruction isn't assigned anymore, but it is used So let us check the logic here. We go into this procedure declaration, we look up the symbol info, we copy the parameter list and save them into R3 address code declaration, and then we generate the body of this procedure, and then we concatenate the parameter generation, the old parameter generation logic with the body of the procedure, and we do not have this stuff anymore, so we can just get rid of this thing and assign the body to the first instruction. That should fix it, and yeah, it compiles. So we can remove this line. We do not need this first instruction at all. We just can assign the call directly to the body field of the result record. The same can be done for the parameters, so we can remove the parameter list variable and just assign this thing to this parameter list, and this can go. I do not know how I use this current parameter is passed to the TIC parameters procedure. We do not need it anymore, so I think that current parameter isn't used further. Parameter, exactly, so we can just use the field access directly as the procedure argument. That works as well. So that actually looks almost fine. We have still to we still have to remove some unused local variables. So we do not generate this parameter list anymore. We do not generate these instructions anymore. We do not need current parameter, we need result, and we still need the parameter count. So that should be fine for this procedure. We checked and these LNTSC parameters once again. Asked parameters used for the current abstract syntax tree parameter index is used for counting the parameters, I think, yes. Current parameter and parameter list. No, yeah, I actually think this is fine. So okay. And let us look into the generated assembly. I do not know. We look probably at this function. It actually doesn't matter. We just find this procedure declaration function. And exactly. So now you can see that we generate just a single instruction. So further we generate two instructions. First, copy the value of the argument into a temporary variable, and then the value in this temporary variable was saved on the stack. And now we just generate a single instruction which directly puts the argument onto the stack. And now but it starts putting the parameters onto the stack with the offset 32. We do not actually need this offset anymore. We do not need pre-allocated stack anymore. So I do not know, we can reduce it to 4 in the first step. I'm not sure whether it will work with the 0, since these offsets are saved in a kind of they're saved in a kind of symbol table, and the lookup function cannot distinguish between 0 and a nil pointer, so it doesn't distinguish between the situation the symbol is not found in a symbol table and when the offset is 0. So we keep it 4 for now. So and now it starts to save arguments beginning with the offset 4 from the stack pointer. Let us look at a function that has more than one argument. For example, this one, TSC integer literal. So we have 1, 2, 3, 4 parameters in these functions, and it generates these 4 instructions. So x10 is x10 as a set is the same as a0, and we copy a0 into, and x2 is, by the way, the stack pointer, so it is SSP register, and we copy r0 with the offset 4, x11 a1 with offset 8, a2 with the offset 12, and a3 with the offset 16. So, and after that the procedure code begins. So this seems to work as we expect. I would like to see whether LNTIC operand stack is set somewhere else. So here it is checked. I think it is used somewhere, maybe not. It seems it isn't used anymore. Can we just isn't used mean it isn't set anywhere? Only read means we can just remove it. Yes, we can remove it here. So we can probably remove it here. And we can also remove it here. That's it. And then we go to the definition of this operand enumeration, and we do not need this stack value anymore. Yeah, there is actually a procedure copy instruction that copies similar instruction from TIC instruction into RTL instruction, and it actually expects that the TIC and RTL operand that similar values like immediate or symbol, so values that the both enumerations have, that they are in the same order. So it basically accepts that pseudo is the fifth value here, enumeration member here, and it expects it in the same position for the ELNA RTL operand. This is actually wrong, and it should be fixed later, but probably not today. We can, I think, just let it be as it is, or just put pseudo in the front of the list and offset. I also think that we do not need things like parameter info anymore. So here it is actually, if we see a variable expression, we just check whether it is a local symbol or global variable, but I think that this one is not a parameter info but temporary info. This is almost the same. I think we do not need this parameter info actually. I doubt that it is used. Parameter info size, parameter info create, ELNA type variable expression. Yeah, it just actually does absolutely the same. One time for parameter info and one time for the variable info, because they are often the same. So okay, let us, and then we return to the beginning of the file. So ELNA type variable expression, it sees the variable expression and it should write the type of the variable. Where is this parameter info create? Create where it is used. So we have this ELNA name procedure parameter, and we actually can just use temporary info instead. Exactly. So we do not create any parameter info objects anymore, so we can get rid of places where we check for them. So at this point we should know that our variable is a temporary info and not a parameter info, variable info. So here we make a lookup. If the lookup is in the local symbol table, if it is not a local symbol, then we look into the global symbol table. But I think that the first condition can be removed. Then probably we will introduce parameter info again when we need it later, but currently they are really handled the same as temporary info. So this compiles. I think that I can get rid of this local variable as well. Then we have this parameter info in the result. This is actually the creation function, and this creation function isn't used anywhere anymore, so it can be just removed as well. And this temporary info should be probably renamed into something like variable info or whatever. So that's fine. Parameter info. So they're basically the same kind of set and variable type. And their offset, we do not this offset anymore too. So this can be removed as well. And temporary info create this procedure. So we have two procedures that do basically the same, I think. It would mean that we can call Elena name procedure temporary instead of Elena name procedure parameter. Let us look where this procedure parameter used. And theoretically we can just call temporary here. So that works as well. Procedure declaration, first parameters and then temporaries. I wonder whether temporaries have the same structure as parameters. So we put parameters in here and then try to remove this code here. It probably won't work. But it actually does. So let us go to this Elena name procedure temporaries. I just interested what it does. So it gets this Elena variable declaration. Yeah, we do not do type checking currently, therefore it works, but I think that judging by the type, actually Elena3 variable declaration is not the same as a parameter declaration. I use Elena3 declaration here. Parameters, current parameter, we just go for the list. Yeah, don't know. So it just uses next and then calls this procedure with the parser node. Temporary parser node, parameter counter and symbol table. Parameter counter isn't used anyway. Then we increment the counter and assign the next element. Yeah, let's just remove it, it's just the same, doesn't matter. Procedure parameter, then I can remove this procedure, I think. So current parameter, we do not need you anymore. we still need the symbol info, and we create a local symbol table here for the current procedure. So each procedure gets a local symbol table, and then we assign it to the procedure info type. So current parameter isn't needed anymore, parameter counter isn't needed anymore, symbol info and new symbol table are used, and the other things are coming from the parameters. Now we exit the editor